My aim today is to try and explain what the internet computer fundamentally is and why people might want to use it. So I'm not going to go into the underlying tech. The underlying tech is pretty complex. We have a large team of very senior research scientists and engineers distributed around the world. We've got a research center in Palo Alto and Zurich and people in places like even as far afield as Japan. And the project involves a lot of cryptography, distributed computing, virtual machines, language design, and so on. And it's complex, and there's some information out there that people can access if they want to do a deep dive into that. But what I wanted to do today was to communicate to you what the internet computer is fundamentally. So you go away, and when you hear the word internet computer in the future, you have a kind of fairly accurate picture in your mind. So fittingly then, the first question we're going to address is, what is the internet computer? So we'll start off thinking about what a computer really is. You can define a computer mathematically, right? So a computer, in essence, is essentially a virtual thing. So there were people like, Alan Turing and von Neumann that created mathematical models describing how computers process instructions and data, right? And you can go from those kind of mathematical, theoretical models of what a computer is to a physical implementation. So most of us think about these physical implementations. Either it's a kind of server machine like this one, right, a physical computer, or it could be a laptop or a smartphone. What's interesting is that, a computer can also be created from a network of computers. And that's what this thing is here. That's actually a kind of recording of the DFINITY network or in some small configuration of DFINITY testnet. And you can see there are lots of these dots represent different computers that are connected together over the internet to produce one larger computer, right? So you may wonder who runs these computers. For the most part, they'll be run by people we call miners. Now, in the context of DFINITY and the internet computer, miners are very, very different to Bitcoin or Ethereum miners, right? So in Bitcoin and Ethereum, miners just compete to solve these puzzles by brute force, which involves expending as much electricity as you can, right? And if you're the first to solve a puzzle, you get to add a new block to the blockchain and get some kind of reward. So DFINITY mining is very different. You have to run a computer that looks similar to a sort of mid to high-end server machine. There are different hardware specifications possible that you can use. And miners will gain scale by running lots of these machines. So we want the internet computer eventually to comprise 50 to within a sort of 10-year window, 50 to 100 million machines, right? So it's a really aiming to produce a really massive kind of supercomputer for the internet that the world can kind of host its IT on. It's a very different thing. So why do people why do miners run these nodes? Well, of course, they earn tokens by doing so. So you can imagine, for example, there are a lot of traditional hosting centers around the world that have got empty rack space, right? And those guys might choose to fill their empty rack space with DFINITY mining nodes so they can earn extra revenues. But anyways, there's obviously a process involved to create a DFINITY mining node. And once you've got the thing up and running, it connects to the DFINITY network, and using the DFINITY protocols becomes part of the internet computer, right? A key aspect of DFINITY is that it scales out its capacity, right? So that means new mining nodes can join the network to increase capacity, so you can install more software on it, run more computations, store more data. And a lot of people in blockchain talk about scalability. DFINITY isn't like pursuing a buzzword. If you look back on the Wayback Machine, the Internet Archives, you'll see on DFINITY.io back in 2015, the project had already amassed quite a substantial amount of research on ways to create a decentralized cloud. It's a very, very non-trivial task indeed, and that's reflected by the kind of people we have in our team, which you can get on the website. So next question, what kind of software will the internet computer run? The answer is universal software that runs anywhere. It's a thing called WebAssembly. Who here has heard about WebAssembly? Okay, so it's good that some of you heard about it. Everyone needs to hear about WebAssembly. It's going to be absolutely huge. So it's the first open standard for universal software that runs anywhere. You can think about it as a kind of Java that wasn't owned by Sun Microsystems and now Oracle. But of course, Java was designed, 25 years ago or something now, and WebAssembly incorporates all of the learnings that have happened since. It's a really fantastic system. It's a virtual machine, so you can write your software in any language you like, potentially, and it will compile down to the WebAssembly bytecode format and run on the WebAssembly virtual machine. The amazing thing is WebAssembly is already inside all of the major web browsers. So we're looking at mass adoption being a thing in the next 5 years. So that means if you want to, right now, you can write WebAssembly software that runs at native speed inside of the web browser. That's not, something that's coming tomorrow. That already exists. It's already there, actually. So, the world's slowly becoming aware of WebAssembly, and we think that it's not just, it won't just be on the front end that WebAssembly is important. It's also going to be very important on the back end. And DFINITY, the internet computer, aims to provide that kind of back end. So if you like, this is about creating an open standard for software that runs anywhere, and that'll be present in what already is present in all the major web browsers. And in the same way that you can use this open standard to write software that will run anywhere, you can also use that open software to write back-end systems that run on another open system, the internet computer, which is a public resource, right? So what we're trying to do is do for computation what the internet did for networking, right? That's why it's called the internet computer. Where did DFINITY come from? It's worth looking at this. So, we do have to trace our history through Bitcoin and Ethereum. I wouldn't define DFINITY as a blockchain project, although you get all of the properties of a blockchain. But it's a decentralized computing network, for sure, and it's a special kind of decentralized computing network. So what was remarkable about Bitcoin wasn't that it was a decentralized network. We already had decentralized networks. We had BitTorrent, for example, right, for file sharing. What made Bitcoin different was that although it was a decentralized network, everybody could share a consistent view of a state, in this case a ledger, right? When you went onto the BitTorrent network, yeah, you could search for files and things like that, but your interactions were kind of limited to whoever you were downloading a file from. The difference with Bitcoin was there was a shared state, and the shared state was a ledger, right? A very simple kind of spreadsheet with 3 columns. In the first column, you have address, right, like a bank account. In the second column, you have a balance of Bitcoins at that address. And in the third column, you have an access control script. And if you can unlock the access control script on one of these rows, you can move the Bitcoins to a new address. Really a very simple thing. But what was so remarkable about what Nakamoto did is that, no matter how big this, decentralized network became, everybody could, share this view, shared the same view of this ledger, right? So, if I transferred some Bitcoins to somebody, everybody else would agree on the network that I also transferred those Bitcoins to that person, right? And that was a remarkable advance because it was, done in the absence of any kind of central controller. Ethereum realized that the shared state of this, this shared state, this shared ledger could be greatly improved upon, and Vitalik wanted to add an enormous amount of programmability. So he drew on the existing concept of smart contracts. And now you could upload smart contracts to a decentralized network. and they could have functions and things like that. Essentially, they're software. And you can call those functions, and the smart contracts have state data associated with them. So we're sort of on the road, really, to what DFINITY's trying to produce, which is sort of internet supercomputer. So the difference between Ethereum and DFINITY is that DFINITY uses a lot of new cryptography and other techniques to greatly improve performance, scale out capacity, provide a much simpler programming model, which is based around this thing called WebAssembly, we just mentioned. And it also has a governance system, so it's not the code is law. So what is the purpose of the internet computer? Okay, it runs, it hosts and runs software, right, that stores data and so on. That's kind of obviously useful. But more specifically, we want to upload to cyberspace software, data, computation, and money, right? And it is uploading it to cyberspace because, yes, okay, it's the internet computer, but it's not really a computer in the way that we conceive of a physical computer. It doesn't have a location. If somebody says to you, where is the internet computer? The only answer is cyberspace. The internet computer is a virtual thing. And it's created by the interactions of all these other computers distributed around the world. So the internet computer doesn't have a geography. You can't say, oh, the internet computer's in Australia, or the internet computer's in Switzerland. No, the internet computer's in cyberspace. So there's this idea that we can upload software and data and money and computation into cyberspace. Like the internet itself can perform the role that things like Amazon Web Services currently do. So we won't go through all of these things in detail because there's not that much time, but we're going to focus on decentralized internet services. But just quickly, we can host private software systems. So one of the reasons for doing that is we can reduce the cost of R&D. We've got a new software development model, right? And the systems on the internet computer can be hack-proof, right? There's no backdoor into the internet computer. And we can provide ways of preserving privacy using advanced cryptography, so you can put data in crypto lockboxes and things like that. So yeah, people we hope will build systems on the internet computer rather than using the traditional technology stack, which is databases and web servers and middleware servers and firewalls and things like that. With the internet computer, you don't need all that stuff, right? The platform's intrinsically secure. It's hack-proof. You don't need a firewall, right? So we hope that people will, build their private systems on the internet computer. We also can support decentralized business infrastructure. So, there are many industries in the world that want to create shared platforms. For example, to track the movements of goods and services and allow people to get financing for invoices and things like that. Or, for example, in America, you can imagine there's lots and lots of different medical companies, right? Massive medical corporations. And medical patient information is sort of spread between them all, and it'd be much better to have a single open platform where patient information was stored. So we can support shared industry platforms. Decentralized internet services, where we'll look at a quick example. So this is where it gets really interesting. So these decentralized systems support a new kind of software called autonomous software. And that means the software can exist independently of some person or organization. So typically today, let's say you wanted to create a dating app. You would get a contract with Amazon Web Services, and you would install you'd create your systems on EC2 instances or something like that. And if you stop paying Amazon Web Services, all of those systems would just disappear, right? Pretty quickly, they'd turn off your servers. And also, you're subject to regulation and all kinds of things, and you control the data, you control the data. And there are lots of problems with that, by the way. I mean, there are hundreds of millions of users now of these online, or like dating apps, right? And we've all heard of Ashley Madison, but there hasn't been a really, one of the big ones hasn't got hacked. But I think a lot of people are probably unaware that that's going to happen, or very likely to happen. If one of these big dating apps makes one misconfiguration error on their network, or they have one disgruntled employee, that's all it takes. And that huge database of chats, and hugely embarrassing chats, right, sometimes, is going to be on the internet. And, if you're unlucky, it'll just be there permanently for the lulls, and everyone will be able to sort of, entertain themselves looking at each other's chats. Or it'll, the hacker will say, hey, you can delete your embarrassing chats for a Bitcoin or something like that. But clearly that's an issue, right? That kind of thing is an issue. So imagine a different world where you can reinvent internet services as open source businesses. And that means that you implement the internet service using autonomous software that runs independently of any person or organization. There's no Amazon, there's no account holder, there's no central server, right? And this autonomous software would have an inbuilt governance system. So you tokenize the service, and the governance system would be operated by token holders, right? And via this governance system, the service would update its software and improve over time, right? In a kind of open source equivalent of this open source software development process, right? Except now the actual business itself is open source, right? And these systems can provide users with real guarantees about how their data is managed. So the Internet computer will provide a kind of crypto lockbox technology that makes it possible for a system like a dating app, which has all these embarrassing chats, that where the creators of the content don't want their information shared widely. They can keep the sensitive data can be kept in a crypto lockbox, right? Which is inaccessible to human beings, but which can still run software algorithms inside, right? So in the case of a dating app, you can imagine that you'd want algorithms to scan through the chat database looking for keywords so it can tag users and match them, right? So using this autonomous software, you can create a kind of open source internet service where some of the data is actually protected by crypto lockbox functionality that guarantees it's inaccessible to human beings, but which allows software algorithms, for example, that analyzes the content of the chats in order to match people, can still run inside. So, hopefully you can see that has a lot of potential. And I also believe that going forwards, once these open computation platforms take root, entrepreneurs and innovators are going to want to build on them to avoid what's known as platform risk. Platform risk occurs when you build a startup on somebody else's API. I'll give you an example. It can even happen to big companies. If you think of Zynga, the social games company, they created this game called Farmville, like I'm sure most of you are aware of, and they grew and they IPO'd. I think they're worth about $5 billion, going gangbusters. And then Facebook decided, hey, I think we should change the way social games promote themselves, right? And the rug was just taken out from underneath Zynga. And, they were a pretty powerful organization, lots of investors worth billions of dollars, but they couldn't stop Facebook from pulling the rug from underneath them. And in Silicon Valley, this kind of thing goes on all the time. It's called platform risk, and VCs look out for it. Like, hey, you're building on this other company's API. What happens if that company removes the API? So recently, a year ago or so, LinkedIn decided that it was going to remove access to its APIs, right? And I think it was just Microsoft and Salesforce were left with access, and there are all kinds of companies that got wrong-footed by that. And, so I think that when the decentralized internet takes off, we'll see kind of mutualized network effects, where innovators and entrepreneurs will prefer to build on the open network and integrate with open source businesses because they provide much better guarantees about APIs and what happens to data and things like that. So I think that's a pretty big use. Of course, the last use is decentralized finance. Things like ICOs, that's not what DFINITY is built for, but it's a sort of inevitability. But there are also models for replicating things like commercial banking, borrowing and lending, and obviously prediction markets are a big one, insurance, token exchanges, that kind of thing. I think, as I mentioned, bunch of features, autonomous software, lower cost R&D, eternal execution. So on DFINITY, there's no concept of storage APIs or anything like that. You just write software that runs forever. The platform is fundamentally hack-proof. You've got privacy protections. Lastly, people often ask, how is the network controlled? If it's a truly open network, who controls it? The network actually uses an algorithmic governance system. It's called the blockchain nervous system, which processes proposals. And this thing, it's a bit like a kind of operating system. It has privileged access to the network. So it's what you call a fully adaptive network. The protocol, the economics of the network structure, which software can and can't run, all of these things are subject to the purview of the blockchain nervous system. It's essentially, it's very, very simple. You create, individuals can create neurons where they stake DFINITYs to earn rewards for voting. And the voting power of a neuron is proportional to the number of DFINITYs it's staked. You can't get your DFINITYs back without dissolving the neuron, which takes a year. And you can configure your neuron to follow other neurons. And there's actually a bunch of content on the DFINITY Medium blog if you're interested in it. But it's an interesting thing because this blockchain nervous system can de-anonymize software potentially, de-anonymize data associated with software. It can freeze miscreant systems. Now, a lot of people say, well, the code should be law, you shouldn't be able to freeze anything. Well, does that hold true for an ISIS slave market? Probably not. So in the end, anyways, this is the kind of channel through which the stakeholders ultimately have their will pursued in the network. What is the network backed by? So there's a thing called the DFINITY Foundation. It's actually a not-for-profit. It's headquartered in Switzerland, but we've got we've got research centers around the world. It's a growing organization. We're growing very, very quickly. So we're trying to build out what we call a NASA for decentralization. So we're trying to build, we believe if you really want the internet computer to host millions of software systems, right, it's a huge responsibility. So it's unrealistic to expect it's 50 research scientists and engineers. It needs to be hundreds of research scientists and engineers behind something that's so important. And it's only when you have an organization that's sufficiently well-funded and has sufficient credibility and has the kind of expertise on board, demonstrable expertise, that we're ever going to see people really trusting a network like this for mass adoption to occur. So lastly, there are my details if you want to get in touch with me. This here is actually a short video of the test network running inside of our Palo Alto headquarters. It's actually, that was just got just shy of 400 computers distributed around the world. They flash green when they are chosen to collaborate to produce the next random number and help create the next sort of piece of consensus. But it's an interesting thing. There's like a paper actually on that particular process. Thanks very much.